What are common TensorFlow deployment challenges? Imagine building a really smart robot that can help you with tasks, but then struggling to get it to work smoothly outside the lab. That's similar to what developers face when deploying models built with TensorFlow. TensorFlow is a popular tool for creating machine learning models, but turning those models into real-world applications can be tricky. Let's look at some common hurdles you might encounter along the way. First, compatibility issues are a big concern. TensorFlow updates often, and new versions might not work perfectly with older code or other tools you are using. This can cause errors or crashes when trying to run your models. To avoid this, many developers use isolated environments like Docker containers or virtual environments. These help keep dependencies separate and prevent conflicts. Next up is performance optimization. Models with lots of layers and parameters can slow down your application or use too much memory. To keep things running smoothly, you need to fine-tune data pipelines, choose the right batch sizes, and sometimes use hardware like graphics processing units or tensor processing units. Tools like TensorBoard can help you monitor how well your model performs during deployment and identify bottlenecks. Another challenge is converting models for different platforms. For example, if you want to run your model on a mobile device, you might convert it to TensorFlow Lite. But this process can cause issues if certain operations or data types don't translate well. Mismatched input shapes or unsupported functions can lead to errors or lower accuracy after conversion. Scaling your models for large applications also presents difficulties. When deploying in cloud environments or across multiple servers, you need to manage resources carefully. Load balancing, fault tolerance, and resource costs all come into play. TensorFlow applications can demand a lot of computational power, which can get expensive and complex to handle properly. Debugging models once they are live is another tough part. Models might behave differently in production because of changing data or unexpected inputs. Limited visibility into runtime behavior makes troubleshooting hard. Continuous monitoring and updating your models regularly are essential to keep performance steady. Finally, platform-specific issues can trip you up. Running TensorFlow on different operating systems like Windows or Android, especially with GPU acceleration, can cause startup failures or slowdowns. Developers need to optimize for each platform's constraints and hardware capabilities. Understanding these challenges helps you prepare better for deploying AI models. It's not just about building the model but also making sure it runs reliably and efficiently in real-world settings. Addressing compatibility, performance, conversion, scalability, debugging, and platform issues is key to successful deployment.